Hello, this is Noah Lee, and I'll be going over the material covered in GVL2. This is Lecture 10 and Lecture 11. First, I'll briefly go over Lecture 10. We discussed primarily the VCNL 4040. We discussed the differences between I squared C and serial, and I think one other connection. The main differences between serial and I squared C is that serial is a very linear method of connection. It basically is just one connection going from the controller to the device and one line back from device to controller. This is a very trivial method. We use this for the terminal along with uploading code to the Core 2. For I squared C is much more expandable. It has individual addresses for each device. um, there is a master clock signal from the primary controller, or actually multiple controllers. There are dedicated data lines both from controller to device and device to controller. Things we touched on was that in I squared C, there can be conflicts with the devices that you connect to the controllers. All devices have I think, factory address. I'm not sure if we touched on if those are reprogrammable. So multiple devices can be connected to the same ports through like a breakout board, but if they have the same address, like two of the exact same device, so if we were to attach two of our VCNL 4040s to the Core 2 over the same connection ports, then they might conflict. We get kind of like a data storm or just garbled data or a mix of both data coming through. And we probably couldn't do much with that unless we have some other method of like parsing that out. We also discussed the VCNL 4040 being just a small specific part of the board that Adafruit made. So the VCNL 4040 itself is like a really, really small center part that has the actual components that do the light sensing and distance sensing. And Adafruit is the company that made the full breakout board, well, excuse me, the PCB that has all of the individual components on it, along with their own library that we can use to communicate much more easily with the VCNL device. However, you still can connect just the VCNL to a controller and then communicate with it for either I squared C or serial if it supports that kind of addressing. We also discussed the connections on the back of the Core 2. In my case, since I have the AWS Core 2, if I take the backplane off of my Core 2, that actually disconnects the battery. In theory, I could probably either like jump the power connections or run it just off of USB-C for testing. But I think so long as we just use one device, I would be able to connect over port A on the front of the device. That should have power, ground, clock, and data on it, so I can connect to multiple devices. Okay, and quick jumping over to Lecture 11, we discussed scanning for addresses over the Core 2 device, how we can pick specific ports and then start that I squared C communication. So I did copy the code from GVL2. This is just basically the structure of how we would set up that scanning. Try and go top down as best I can. So we start with just a simple kind of like sanity check on scanning for I squared C. We set up a byte to store the I squared C response, and then the device is found. We have a Boolean array for which devices we discover. We set up a wire through one of the C++ libraries. This is to communicate over I think it's over the serial connection. Actually, sorry, the I squared C connection, pardon me. We initiate this wire in the same way that we do the M5 up again. This means the pins that we're using to communicate with, in this case 32 and 33. We then select the clock rate. Yeah, that's what this is, the clock rate that we're looking for devices. We then iterate over all 128 different addresses that the devices can be at. This we just found from a quick Google search. First, we initiate the wire, start a transmission, then end transmission, start transmission, and then end transmission, and pass this to the I squared C response. We did go over some kind of I2C error OK enumerator. I didn't have that for some reason. So if I just do I2C or okay, for some reason this isn't found on my device, so I just left it with 0. If we find a response there, then we set that address in our bool array to true, and then increment our known devices. Then, if there are no devices, we just say found nothing. Otherwise, we say, yep, found something. This is how many. And then we go again over the whole array. There is an address at that location. We print where the address is. And that's pretty much everything that we covered in these two. I can quickly go ahead and restart part two. And then if I open it over a terminal, start again, think, go. There we go. So this does run, it just tries to scan, but I don't have anything connected. I hope, I'll just say a quick comment, I guess I'll add. If we do have any other projects that will need the hardware components, I'll probably have to discuss with Raymond about splitting using that since I just have my Core 2, but I can of course run the code and upload it and make sure it doesn't just explode on me. But yeah, okay, that's everything. I'll go ahead and call it here. Thank you very much. Bye.